These next few slides and videos are going to walk you through how to solve a free body diagram force problem. So the problem reads, calculate the force you would need to pull a box on the ground to accelerate it at 2 meters per second. The mass of the box is 3 kilograms and the frictional force is 10 newtons. Your first step was to draw a free body diagram. So let's see how well you did. So you need to compare yours to mine. So this is being pulled on a ground. There's my ground. Here's my box. Since it's being pulled on the ground and it's not specifying at an angle, we can assume that it's just being pulled. So I'm going to call that my force applied. Anytime you have a force applied in the opposite direction, you have your frictional force, which it says is 10 newtons. So I'm going to go ahead and label that. Because it's being pulled on the ground, I also have my force of gravity, and I have my normal force. Remember that your normal force is always perpendicular to the surface. All right, so that should be your free body diagram. Now, the next step of this is going to be to write out givens and unknowns for each axis. Okay, so let's look at that. We're going to look at the x direction first. So remember in math, this is your x direction, this is your y. So in my x direction, I have my force of friction and my force applied. I do not know my force applied. Now my y direction, I have my force of Newton and my force of gravity. It's not moving in the y direction. So I'm going to sit here for just a second and go through your summation of forces in the y direction. Your force of Newton is in the positive y direction, so it's going to be positive. Your force of gravity is in the negative direction, so you would minus it. But your summation of forces in the y, because it's not bouncing off that table, is 0, which means these are going to be equal, and I don't even need to worry about it. So I'm not even going to focus on the blue. I'm only going to focus on the white. You are looking for your acceleration. You have your acceleration. You are looking for the force you need to pull it. So you're looking for your force applied. What you have is your acceleration in the x direction, which is 2 meters per second squared, and you have a mass. Your formula for this, there's 2 of them, summation of forces in the x direction. So you have force applied, which would be positive because it's moving in the positive x, and force of friction, which is moving in the negative direction, so it would be negative. And then the other equation that you need to be familiar with is your forces equal mass times acceleration. Because it's moving in the x direction, I'm going to put a little x right there for acceleration and right here for the forces. Now, I don't have enough information to use this first one yet, but I do for this second one. So my forces in the x direction have to equal my mass, 3, times my acceleration, 2, which is 6. So then I can take this and plug it in here. Summation of forces in the x direction equal force applied, positive, minus force of friction, opposite direction, so it's negative. That's why I changed it to minus. My forces in the x direction is 6, equals my force applied, that's what I'm looking for, minus my frictional force, 10. Add 10 to both sides, and you get that your force applied has to be 16 newtons. And that's your final answer. So recap, you draw your free body diagram, you list out what you have in the x direction, what you have in the y direction. You take your formulas, you have summation of forces in one direction, you take your summation of forces in the other direction, and then you realize if it's moving that you can use your force equals mass times acceleration.